Dear friends, in this video, we will discuss an example problem where normal distribution is applied. The problem is stated like this, problem for discussion. The mean weight of a morning breakfast cereal pack is 0.295 kg with a standard deviation of 0.025 kg. The random variable weight of the pack follows a normal distribution. 3 questions are asked. What is the probability that the pack weighs less than 0.28 kg? That's the first question. Question part A. Then B, what is the probability that the pack weighs more than 0.35 kg? Then the third part, C, what is the probability that the pack weighs between 0.260 kg to 0.340 kg? So let's see how to do it. A simple code in Python, Jupyter Note. We will explain that now. So the first one, what is the probability that the pack weighs less than 0.28 kg? To do all the 3 parts, A, B, and C, we first import stats from SciPy. From SciPy, import stats. Since sometimes we get warnings and all that, we don't want the warnings to be displayed, I put import warnings, then warnings.filter warnings ignore, so that it is ignoring. So I'm executing this first in order to do the problem. So I have executed that. The computer still gives warning, and let's ignore that. From SciPy, import stats, then import warnings, warnings.filter warnings, ignore. It should normally accept it, but doesn't matter. Now, use the function statsnorm.cdf cumulative density function within brackets. We put the parameters for lesser than probabilities such as finding x or z less than a specified value. Use 1 minus stats.norm.cdf for greater than probabilities such as finding x or z more than a specified quantity or value. So this is the function. I take this now. First, the diagram. What is the probability that the pack weighs less than 0.28 kg? Visual for part A. You can see this is the diagram. You can clearly see here. Diagram, they are not necessarily drawn to scale, but to explain the problem. 0.295 is the mean, and it is left of the mean. Less than 0.28 is this area which is shaded. And then I write the simple code. What is the probability that the pack weighs less than 0.28 kg? Mu, mu I put here, mu is equal to 0.295, sigma is equal to 0.025, x1 is equal to 0.280. This is the ordinate, and we want the probability less than 0.28. So P is equal to the probability, which is stats.norm CDF x1 0.28. I put here. Mu is already taken by the computers, 0.295, sigma, they're all defined, I put, and comma 4, round this to 4 decimal places so that the output looks elegant. Print within quotes the probability that the pack weighs less than 0.285 is P. When I execute this, let me show you what happens. So let me just remove this current outputs clear. I put here. Now I execute this here, this code. Run this. then you get here 0.2743. In other words, the probability that the pack weighs less than 0.280 is 0.2743, or 27.43% is the probability that the pack will weigh less than 0.28. This is answered the first part of the question, A. Now let us look at B. What happens is, you are asking what is the probability that the pack weighs more than 0.35, and look at the diagram now. It is right to the mean and 0.35 is here. We shade this and this area is wanted, and therefore, as told earlier, 1 minus the cumulative I should do. So I put x2 is equal to 0.35, which is this ordinate, and mu is same. We have already defined mu and sigma. They don't change. And P is the probability rounded to 4 places as before. 1 minus stats norm dot CDF, stats dot norm dot CDF, x2 comma mu comma sigma, 4 decimal places rounded, print the probability that the pack weighs more than 0.35 kg is within quotes and P. And the moment I execute this, I'm going to get the answer. Let me just put here, clear all the output here and execute this now as before. Run this code. So you get here the answer 0.0139. In other words, the probability that the pack weighs more than 0.35 kg is 1.39%, or in decimal 0.0139. So simple to write in Python and enjoy the solution. Now, let us also look at part C here. What is the probability that the pack weighs between 0.260 and 0.340? That is 0.26 to 0.34 kg range. Now look at the diagram. This is 0.26. This is 0.34. And you want this area. Therefore, it will amount to adding 2 probabilities here. And that is, I have to do 0.26 to 0.295 and then 0.295 to 0.34. So let's see now how it is done here in the code. So let us define x3 is equal to 0.26 and x4 is equal to 0.34. So what it happens is that to do 0.26 probability and 0.34, I define it as the P1 and P2, and then I'm saying you want in this range. Therefore, what I do here is first I calculate area up to 0.34. Because adding these 2 parts is difficult, we have to manipulate depending on the function stats.norm.cdf. So all I do is find out the area up to 0.34, then find out the area up to 0.26, subtract 0.34 area minus 0.26 area, you get the answer. So what is the probability that the pack weighs in this range, 0.26 to 0.34? Define x3 as 0.260, x4 as 0.340, P1 equal to stats.norm CDF, x3 mu sigma, you enter. P2 is stats.norm.cdf, x4 mu sigma, you enter. P is rounding P2 minus P1. You can see the diagram again. Area up to 0.34 minus area up to 0.26. That's what I have said here. Round it to 4 decimal places. Then print the probability that the pack weighs between 0.26 to 0.34 kg, and the within quotes comma p, which is the computed probability. Run this, you get a solution. The probability that the pack weighs in this range of 0.26 to 0.34 kg is 0.8833, or the probability is 88.33% for a randomly chosen pack weighing between 0.260 kg and 0.34 kg. So beautifully done in Python. Thank you very much. I hope you will understand. You go through the video again. You could have, of course, done it as Z, then you have to write a code for computing Z. The answer you can get both ways. That's the beauty of writing a code in Python. Thank you very much. Go through the video again to have clarity, and that's it. And thank you very much. We will see you soon with another problem or another video. Thank you very much.